Now we get to the first critical part of Paradise. The way Paradise works is that it looks at your data in intervals, and you will have to spend a little time on selecting intervals. We will show you how you do that. It's good to know that if you follow some basic rules, it's actually not critical how you select the intervals. So let us take you through this step. It's useful to zoom in a little bit. Let me start in this area here. Here we are. Well, actually, let me zoom in a little bit. Let's just say we're starting here. Now, trick number one for making life simple for yourself later on is that you need to select intervals as narrow as possible. And that could mean that you try to focus on one peak at a time. Let me show you how you select a peak. You press the button called Select Interval, which is here. And then with the crosshair you have to select the left part of the peak and the right part of the peak. And let me give you a tip on how you can make life simple. And that is by focusing on one peak only. Now you see here that there's clearly a peak here, maybe even several, and there's a new one in this part here. What I would suggest to do is to focus on one peak at a time. So now I'm trying to get the best possible representation of this peak only, not really considering the smaller peak. So maybe I will stop at this point. You see up here that now I have defined a peak from starting point 3.9 to end point 4.4. Now I can define a new interval. For example, one that's focusing on this part here by clicking once here and once here. And now you see I get a new peak. Now there might actually be more peaks here. So it seems like there could be more going on here. If we want to be a little exploratory, we could mark this whole area. So from here to here, and then see what comes out of it. Let me move on just a little bit. Here we have another one that's very simple. It might be just one peak. So I'm going to say select interval, and I click once here, and I click once here. Preferably, it's nice to have baseline resolution, but it's not critical. What is mainly critical is that you have a good representation of the peak that you're interested in. So don't worry about taking half of another peak, for example. Let's see if we can find a good example a little later. Here's actually also a peak. I shouldn't forget about that one. I may want to zoom in a little bit. Ooh, risky. Come on. Oh, you see, what I did now was that I accidentally created a wrong peak. So I need to delete that one. I'm gonna click here and say delete interval. And I delete it. Now I can zoom in. Okay. Let's see. Select interval, left, right. Select interval, left, right. Let's see if we can find a more complex region. This is a nice one. Now, In this particular region, you see that we have several peaks close to each other. So what I suggest is that you first do an interval, focusing on the leftmost peak only. So like this, for example. And then you do another peak selection, focusing on the rightmost peak, on numbers of peak. And maybe disregard this funny shift that you have in the data here, like this. Okay, we should do all the peaks, but we're not going to do that here. So I mainly want to move on to here we have a nice one. So let's see, I will zoom in on this part here. Okay, how would you do this one, Pixel?
So if you have such a complex and noisy chromatographic region, and you are not sure how many components are here, or how many chemicals are eluting, it's advised that you try your best to fit one peak in an interval, and then select each separately, rather than including all these peaks into one interval, because that will make the validation of the resulting model complex and difficult, and it will be difficult to understand how many peaks are in there. But if you really have a problem, for example, in this region, if you have a problem in this region to select an interval between this smaller peak on the left side and on the right side, the bigger peak, then what you can do instead is you can actually take, for example, the small peak separate, and don't be afraid to take a little tail of the neighboring bigger peak, because if they have a different mass spectra, the neighbor part of the bigger peak will be deconvoluted as a separate component, and the smaller peak itself will be deconvoluted as a different component, only if they have a different mass spectrum. So it's fine if you little bit overlap when you select the intervals. So, and you can do the same way here. So you can take half of the smaller peak and then the full of the bigger peak. And in that way, you can select the intervals.
Okay, and what you really need to do, of course, is to select all the different intervals we have. But we're not going to do that here now. We can we can press this show intervals, and we can get a visualization of what we have chosen. As you can see here, now I zoom too much, but like this. Here we are. Once you are happy with your intervals, what you can do is that you can save the intervals in your project folder, like this. And then we are ready to move on to the next step.
Yes.